Hi everyone, and welcome to WiseSource's DevSecOps Virtual Summit. My name is Victoria Oiknina, and I'll be moderating this webinar session. I'm pleased to introduce our third session of today's summit titled Container Security at the Speed of CICD, which will be presented by today's speaker, Tim Chase, Director of Security at Healthstream. Tim, welcome. The stage is all yours.
Thank you. I appreciate it. Thanks everyone for joining us today. I look forward to presenting. So before we get started, I just want to give everyone a brief background on myself to kind of know the journey that I went on and how I got to learn a little bit more about containers. So I am currently the Director of Security at Healthstream. So the CISO here, I'm in charge of everything from infrastructure security to cloud security, application security, the whole realm. And I've been doing security for about 15 years in various roles. So started out in the application security field and moved around to a couple of different jobs where I started some application security programs and really brought them up. And one of the things that I've really spent a lot of time on the last few years is really cloud and containers, because it seems like at this present role, at the place that I was previously, that's really where everything is going. So I've spent a lot of time in the AppSec cloud container world. And so in kind of in addition to all of that, I am an instructor on LinkedIn Learning. And so some of the things that we're talking about today, some of the principles are actually out there on Lynda or on LinkedIn Learning for anybody who might be curious and want to know more and get some more hands-on. So that's me in a nutshell. And so at the risk of being repetitive and redundant and hearing things that you've already heard, I always like to start out with a couple of slides just kind of defining to me what DevOps is and how that fits into everything, because the key of CICD and DevOps and moving faster, that is a key. And we hear the term thrown around a lot, but I don't always agree with what it means, and I don't think we actually always know what it means. So I found this quote several years ago, a couple of years ago, that I've used a few times because I think it's a great summary of what DevOps is, and it's from the AWS blog. And it means, it says, DevOps is a combination of cultural philosophies, practices, and tools that increases an organization's ability, applications, and services at high velocity. So that's a lot of words, but I think it sums it up very well. And some of the things I'd like to hone in on here is that it's cultural philosophies and practices. It's a cultural thing. And it's tools. You have to have the right tools to support it. And then at high velocity. So kind of the entire principle behind DevOps is being able to do things quickly. And so, you know, when I look at what DevOps is, it's really kind of was founded, and its history is bringing all the teams together that were disparate in the past. So instead of QA, instead of infrastructure and development, and you have all these separate teams, and you would have almost kind of a step-by-step process of developing things and supporting things. And that moves everything together, right? And that was kind of born out of a sense of frustration of how long it took to get things done. So in order to really do this properly, there's a cultural change that has to happen. It's not just a magic wand that gets waved, or one day you wake up and decide to be DevOps, right? You have to have a cultural change from the bottom down and restructure how you do your programs and develop your applications and everything. And then the overall goal really is to reduce your cycle time, to be able to deliver quicker, whether it's features, enhancements, support, releases, whatever it is. That's the overall goal. So one of the problems kind of getting to where we're going today, one of the problems with DevOps and that we've been challenged with in the past is that, you know, I can tell you that I felt over the past several years that we were the long pole in the tent, so to speak, and that may be a southern way to say that, you know, security was kind of the thing that took the longest, and we were always being pushed to be faster and faster and faster. And security, you're resistant to that, right? Because you don't want to do things quicker and sacrifice quality and security at the same time, right? So, so DevOps really changes our mindsets around security. You have to go faster. have to be more accurate. You can't be faster and less accurate, right? You need to be more accurate, quicker, more flexible, so that if there are changes, part of being agile and DevOps is being able to adjust on the fly, and not have to adhere to a strict schedule. And so being flexible. And then ultimately, and this is kind of really important to me, one of the things I like to preach is it kind of shifts the responsibility to security being owned by the DevOps team. It's managed and audited by the security team, but just like everything else, we like to give the tools and the processes to the DevOps team to be able to do it themselves rather than relying on my security team to do it. And so at that point, that's where the term DevSecOps enters the picture. So kind of the idea behind it is to incorporate security principles into DevOps, right? So take all of the things that we talked about with DevOps, the integration of teams, the flexibility, the quickness, the speed, agility, all of those things, combine them into the DevOps principles, right? And make them incorporate all of our security principles in with it. And then ultimately make developers responsible for security, which is one of those things that makes developers potentially nervous and security people nervous, right? In essence, it's giving them the tools and the processes to do the job, with security being more of an audit function. And then ultimately making it a shift in culture, making everybody understand where security lives. And I find that a lot of DevOps teams are willing to adopt it because it makes their lives easier, right? Rather than having to go to you every time, if you empower them, it makes their lives a lot quicker to make sure that they can go at the speed that they want. So kind of, fast forward to containers, and where does that leave us? So containers are one of those things that it took a while to really come up with a good security solution for. I can tell you that when we first started looking at containers and trying to get our heads around them, I felt like development and the development teams were ahead of security, right? They were wanting the latest, the greatest, and they wanted to go a container route. And so from a security team, we're kind of left going, well, heck, how do you secure them, right? And so one of the things that you have to understand first, I think it's very helpful, is let's talk a little bit about what a container is and what are the different parts of it that you need to secure, right? I think that's the first step in going down this process. So in essence, containers are one package for everything, right? So as opposed to having to install several servers and having virtual or physical hardware and having to apply the operating system and then the patches and then the libraries, and you end up with 6 servers, right? Container is one package, so it really allows you to easily deploy between environments. You're not left to think, oh, okay, does development set up exactly the same as QA, which is set up the same as prod? It takes that out of the mix, right? Because your container is one package that has your app on it, and so it's just ready to go. So what you test in one environment will be what you test in another environment. Okay. So and so our security thought really has to change, right? So in the past, we really looked at it as, okay, so we understand what we have to do. We have to look at the host operating system. We need to run our vulnerability scans against it and make sure that it's up to date on the patches. And then we need to make sure that the server themselves are set up according to proper CIS benchmarks or NIST configurations or something like that. And then we perform our application security testing, and we perform our code reviews. And all of these things are a little bit different now because you've literally got a packaged file, a Docker file, which just modifies it. So security really has to change and adapt to it, right? And so we also have to think similarly to how do you secure between containers, right? So if you think about virtual servers and how they're run, that's the hypervisor vulnerabilities are always something we have to be thinking about. Is what if somebody were to find a flaw in VMware and they could get from one server to another through VMware itself, right? Through no fault of your own in the operating system, right? And so the same thing is true of containers. So we'll walk through this. Here's kind of a visual example of what a container is, right? So like I mentioned, you package your apps into a single container for deployment. It's literally, containers can be complex. The systems can be complex and have several microservices that make up one actual program or application. But they can also be as simple as downloading one file, and you could install Docker yourself and download the WebGoat Docker file and have WebGoat up and running on your machine to do some testing in about probably about 5 minutes, right? It's really that easy. There's no setting up a Tomcat. There's no setting up of a database or anything like that. So you can see here an example of what this looks like. So you've got your normal infrastructure, which you always have to have, right? Your server that actually will host the files, and usually it's Linux. You can do Docker or containers on Windows, but it's not as common. So, and then you'll have your Docker host, and then you have all of your containers. So you could have your app server on one, your database server on another, or you could have several applications or microservices running on your Docker host machine. And this is kind of what it actually looks like. So if we want to look through each of the individual levels here, and we'll talk through each of these in specific before we go into an actual example. But the first part of when you're breaking down a container and where you should look, these first two kind of go hand in hand together. Right? So you have application security and you have library security. And what those are the actual applications yourself, just like anything else. And so when you're looking at an application itself, a web app that's running, the testing of that would be very similar to what you would do, right? It would be abstracted from the container, and it would run just like any other web application. So you could use your normal static or dynamic testing to do that. But your libraries, your jar files, your .NET DLLs, things like that, those are actually embedded into your Docker. So that's kind of the first part of securing your Docker container. And the first place you should look is we need to make sure that all of the libraries and the supporting files, whether they're open source or what have you, that we use are up to date and don't have any security issues. So that's the first place and the first logical place that you would divide up your security review. After that, we need to look at the actual Docker configuration itself. So your container host, Kubernetes, Docker, whatever it happens to be, they have best practices associated with how to set them up, right? And not only how to set up the Docker host, but some of the configuration settings that you have on the Docker container image that's running as well. Right? So if you think about this logically, and sometimes it gets a little bit confusing, you will have your as shown here on the bottom blue, right, you'll have your Docker host, which is running on your Linux box, and that host will support multiple Docker images running. Okay, and so one of the things that you have to keep in mind is that, just like with anything else, there are configuration settings that are best practices. If you go to someplace like NIST or CIS benchmarks, there are best practices on the CIS benchmark site for Docker and how to set it up correctly, and there are some agreed upon standards. And so that's kind of the next step here, is making sure that your Docker is set up correctly. Okay. And then thirdly, overall, you need to consider how am I securing the entire Docker host machine, right? How am I preventing application 1 from talking to application 2? Things like that, right? You want to make sure that you're not allowing any sort of container escape. Okay. So let's walk through these a little bit more in depth, and then we'll get into an example. So like I mentioned, the first thing that we want to dig into a little bit is library and application security. So just like anything else, you need to look at the libraries. This is something that's very important to make sure that your libraries are up to date. It's important enough that since 2013, OWASP has had it in there. The last one I looked at is like A9, but it is in the OWASP top 10 of common things, right? And it's very it's become very important, and if you look at things like struts, that obviously Equifax has become synonymous with, that was something that was due to an outdated library in the struts library. So those kinds of exploits are very real, which is why it's always on the OWASP top 10 in the latest few revisions. Okay, so and it's easier to miss with containers because you don't always, if you don't understand how to break a container apart, you may not realize that all of the application code, all of the libraries and all of that, they're still on the container, right? The Docker file is literally a list of instructions on how to build this thing out, which would include all of your libraries. So you need to keep that in consideration, is that you are hosting an app, you do have code, and you do have libraries, and so that suffers from the same potential vulnerabilities as any other application does. The next one is the Docker configuration. So, just, I mean, as good as Kubernetes and Docker are, right, they do suffer from security vulnerabilities just like anybody else, and there have been some good ones. And what that means is that the host software that runs all of your containers, that's vulnerable to security misconfigurations and outdated versions, just like anything else, right? And so you really need to keep in mind and be monitoring the actual configurations and best practices of the host itself. And so once again, if you go back to the OWASP, this would fall under, the latest one is the A6 of the OWASP top 10, right? Security misconfigurations, just like you can misconfigure Tomcat or IIS or Apache or SQL, you can do the same thing exactly with Docker, which is why you should look at using some sort of benchmark to guide you, okay? And I reference once again the CIS benchmarks for Docker. If anybody doesn't know about the CIS benchmarks, you should check them out. The actual benchmarks themselves are there for no cost, but they have some additional features that you can pay for if you want. But they're an invaluable resource of people out in the community that just provide kind of the best practices and so forth. So definitely check those out. And then finally, the actual host security itself. So like I said, securing the host. People have probably heard of VM escape vulnerabilities, meaning if you're running VMware in your environment, there have been vulnerabilities in the VMware software that would allow someone to escape from one VM to another and get access to a box that normally they shouldn't have access to and communication with. So that's one thing that we need to make sure of here, is something like container escape, right? So that's kind of the term here, is escaping one container and talking to another, right? Container A shouldn't be talking with container B, but it does. So you need to be aware of keeping of those type of things, monitoring for that activity, and keeping your version of your container host software up to date. And so just kind of putting it back all together, so hopefully this makes a little bit more sense. These are really the 4 areas that we're gonna that you can look at when you're trying to divide up a container and know how to secure them and make sure that you have a process built around it, right? So your application security, your library security, your Docker configuration, and then finally your overall host security. Okay, so what I want to do now is I want to walk through an example. And the way that I want to walk through this example, I do have screenshots. I have taken away the, I've kind of blurred out the name of the application of whose screenshot that I use, because I didn't want to come off that I support one vendor or the other, but I felt like logically it would help if we could see kind of how these things work, right? So, and the other way that I want to walk through this is I kind of want to walk through, kind of presenting a lot of information. If you went to other sessions, you've probably getting a lot of really good information. And I wanted to provide a logical step-by-step process of how you could roll this out, rather than rolling it out all big bang one at a time. So, with that being said, like I said, the first place that I would start when you're looking at securing your containers is to start with the vulnerabilities. It's the easiest one to start with. okay? And so you're going to be looking for questions like which libraries are out of date, which ones have open CVEs against them, so common vulnerabilities that have been published, right? So you're going to be really looking for those. And our goal here is to really get a clean image at first before we move on to the next part of securing it, right? So, and usually the way to do this is really easy. You can just start with, most of these container security tools are command line driven. There are some that are not, and there are some that have GUIs, and makes it a little bit easier, but you simply provide your container and you pass your container into the software via a command line, and it spits out the results of your library scan, right? So to kind of just give you a screenshot here of what this would look like, right? So this is it, and so you can see here that in this particular example, there's a list of vulnerabilities, and it tells you which CVEs are open against it. You can click and you can look at it, right? And then the next part is, how severe is it? What's the risk score? And how many impacted images do you have on this particular one? So if you have 6 images that are subject to the same vulnerability, it's going to tell you that. So hopefully that would help you bubble it up to make sure that you get those fixed and resolved first. Okay. Okay. The next step is kind of where the CICD comes on, right? So we didn't really talk about what CICD is, but it kind of goes along with the principle of DevOps, right? So it's continuous integration, continuous delivery, right? So making sure that your development, your deployment process is seamless, whether that goes from, from development into test into production. That's kind of what the CI/CD stuff is. So whenever we're doing security in general in DevOps, but when we're talking about container security here, the idea is always how do we integrate that with the development process? Like, I know I mentioned, the first step is as easy as running a command line, right? But that goes back to the long pole in the tent example that I mentioned earlier, is you don't want to have to, every single time a new container is deployed, manually run that through a command line, right? That kind of makes it non-DevOpsy, right? So the idea here is that we would integrate it with something like Jenkins, right? And I felt pretty good about using that word. And I think when you think about DevOps and CI/CD, I mean, Jenkins really is your friend, right? It's kind of synonymous with it. It's hard to separate those these days. And so this next step is when you actually take the vulnerability step that you just did, but this time you incorporate it into the build process. So when your developers are checking in their build and they're running through their unit tests that they should be doing, you would incorporate a step, you would incorporate a job in there that would actually scan your application for vulnerable libraries. And the idea here is that you would set a threshold so that if they have any, anything that is has an open CVE, shut it down, right? Or something along those lines. Like, you can set whatever threshold makes sense for your organization. You would set that and you would automate that so that if they check in a container into Jenkins and the unit tests are going and all of that, and then it goes to the next step, which is your container security platform, and it finds open vulnerabilities, it would fail it and not allow it to be promoted to the next environment, right? That is what DevOps and containers looks like. So let's kind of walk through that a little bit here. So if you're familiar with Jenkins at all, this is somewhat what it would look like. So you've got your static. You would come in here. You would set up a static analysis utility in essence. And then you would just set up your integration, right? So you'd come in here and you could plug in the information for your container security tool, and then add that as a step, and it would incorporate that. And you could add anything that you wanted. You could say, add it. You could fail your build. You could choose to not fail your build. You could, whatever makes sense for your organization, kind of in the time you could do it this process. And on the next slide, I was going to show you kind of what that looks like when you do that. Right? So every time that you run a build, it would look something like this, and it would give you kind of an idea of what each build would look like, and you can see every time that the actual Jenkins process ran here. Okay. And this is what the container security. So hopefully, some people like screenshots, some people think in a diagram, and I do use a name of a tool here, but it's open source. So like I said, I felt pretty good about using this one. This is really what it looks like. So you have your developers here that are doing their coding, right, and building the containers and all of that. They would check it in to Jenkins, and then Jenkins would automatically send it to, in this particular case, it's showing the open source tool Anchor, and then, but you'd use. It would do its evaluation, and then based on its evaluation, you can choose what you want to do. You could fail it, right? If it meets that threshold that I specified, you could fail it. You could give a warning. So if you want to say, you've got a couple of libraries that are out of date. They don't have any CVEs yet, but if they maybe or they are outdated, then we're just going to give you a warning, right? Or you could pass it if they're clean, right? So the reason I mentioned, if you go back to the first step of the libraries, the reason that I mentioned to do it manually first is you're really going to frustrate a lot of developers if you turn this particular process on and fail them out of the gate, right? So it's best to get a clean run, clean up the image first, because I can usually guarantee that the first time you run a container security tool against libraries, it's not going to be clean. There'll be something that they'll have to clean up. Libraries are just one of those things, stick out there, and it's not something that's too exciting, and so they don't always go back and get them updated, right? So that's why I suggest start manual first and then move into this Jenkins process. Moving on to the next step, I mentioned that we're going to look at the best processes. So this comprises several things here. So we're going to ensure that the images are set up with the best practices. Like everything, there's configuration benchmarks for them. Some examples here that I mentioned are making sure that there are no keys in your container, right? Encryption keys are useless if you store them in the place in which you are trying to access the encrypted data, right? So making sure you don't store keys in the container would be an example. SSH running in containers, that's usually a no-no, unless you have a very, very, very specific reason to do it, but sometimes that gets turned on and enabled. So looking for things along those lines are some examples here. And then once again, the kind of the CICD part of it comes into the continual monitoring for updates. So just like the slide that I showed you previously, you would incorporate this compliance standards and adherence to best practice in the CICD process. So if for some reason it scans it, SSH is running, bam, you would shut it down, right? So that's kind of the idea behind it. Eventually, once you run this a few times to make sure that it's where you want it to be. And this is kind of an example of that same tool, what that would look like. There's a screen with several different configuration options that you can turn on or off, and you could do a whole another presentation on best practices around Docker container security. But there's, you can decide what's best for your organization and turn them on and off according to what risks you're willing to accept. Thirdly, and kind of the final part that I mentioned about what we should be looking at with the runtime is we really need to, just like with anything else, the operational aspect of containers running, they need to be monitored, right? So, and what I mean by that is just like when you're in production, on normal servers, you have some sort of monitoring setup. You got your SIM hooked in. You've got potentially some sort of security tools monitoring for weird activity happening between servers, things like that. You need to be looking at with containers as well. And it's a little bit trickier because Normal tools don't know what to do with containers, so you almost have to look at one of those container-specific security tools here, right? Because these things need to be looked at the host level, the Docker host level, not at the operating system level that the host runs on. So that's why this is kind of one of those specialized things. So you should be monitoring for things like container escape, right? I mentioned that. So if your tool notices all of a sudden that two containers are talking to each other that they've never talked to each other before, and all of a sudden they are, something like that should be flagged. That's anomalous activity, right? That's runtime protection. Unusual open ports. So if all of a sudden, you've got your containers that are running and the app's running, and all of a sudden port 22 is opened up, right? And there's communication happening over port 22. That's weird, and that shouldn't be happening, and so that's something else that should be flagged here, right? So, and then once again, data being exfiltrated. So if all of a sudden a lot of data is coming out of a container, that's probably something that's very odd. That should be something that would be flagged on a runtime. And to kind of give you a screenshot of that. That's kind of, and then finally you would integrate it with your SIEM, like I mentioned here. So then this is kind of what it would look like. This is a screenshot of the real-time protection here. So you can see that some of these containers that are running have obvious security problems. In this particular container, it's got some things that it's telling you are not good, right? They've got a hijack process, and they think potentially you might have like a virus on your system, and it's alerting you to that. And it knows it because it watches the activity, it learns and user behavior, and knows what to expect and what's normally running on these containers, and it flags things when things go awry or things start appearing out of the norm. So, and once again, you would probably take this information and you would forward it to your SIEM, right? Just with anything like this, having a lot of different tools to go to doesn't help. It doesn't really help. So this is good for digging in deep and seeing what's going on. But you would actually take this information and it would go to the SIEM, right? And that's where the continuous integration delivery happens with this particular process. So that's the real-time feedback. Is there's always monitoring happening in production, and then anything there that seems anomalous would get sent to your SIEM for the security team to act on. And just, I got a couple final thoughts here. One of the things that I've found when looking and doing investigation and working in this space over the past few years is that the tool space is actually kind of surprisingly immature here. And I could name a couple of tools off the bat that I think do this well. And that's it, which for the security space is really unheard of. Usually we have to sort through a dozen different tools that say they can do it best. But that's, so when you're looking for the right tool for your organization, just make sure that they can incorporate all three of these aspects, the library aspect, the best practices, and the runtime aspect, because there are a lot of tools out there that will do the vulnerability one, but won't do the rest. And so that's not really, you're leaving a lot of things on the table at that point. So, just keep that in mind as you're really doing research here. Security teams lack container skill. It's one of those things that still, surprises me, and I guess it shouldn't. I mean, and developers and people like that are usually wanting the coolest, neatest, greatest stuff, right? And so the security team doesn't always keep up like they should, and that's just, it is what it is, right? And sometimes, when there's a new development language out there, the security tools to test it may be 6 months or a year behind. Like with Golang or some of the new JavaScript languages that are out there. The security tools are still maturing. It's the same thing probably in the container space. But I think the security team as a whole, we need to be taking an active interest in figuring this stuff out, because as I talk to different security teams, their eyes kind of glaze over when it comes to containers and what that actually means. So hopefully presentation like this will help break that up. And then, like I said, most tools lack coverage. So it kind of goes to the first one, but I can name you probably 6 tools right now there's 7 tools that can do the library part, right? Because there are a lot of tools out there that are good at libraries, and they'll even do it in containers now, right? They've added some features to be able to look for outdated libraries on containers, but they don't do the rest of it, right? So you're, like I said, you're leaving stuff on the table. You're not looking at the runtime aspect, which is very specialized when it comes to containers. You're not looking at the best practices and scanning for best practices, right? Those things are equally as important from my perspective. And then, you know, I always like to put kind of a next steps in here. So that's great. I talked for 40 minutes, which is fantastic. But now what, right? So what I encourage everyone to do, whether you're a DevOps practitioner, a security practitioner, whoever you are, I just encourage you to play around, right? And there are free things out there that you can use to test this out, right? It's not like you have to go out and buy a $100,000 product in order to figure it out, right? So I always encourage people to just go and play around, right? So the way that I do it is go and download a Docker container that you know has security vulnerabilities. And the one I always go to is WebGoat. Everybody knows WebGoat, the security world. They've got a Docker container now. If you go to the OAuth site for WebGoat, they'll take you, and it's out there on the Docker repo. And so just download it. It'll take you 5 minutes max to do that and get that up and running. And then just look at something like, I mentioned Anchor. It's an open source product. There are some enterprise level features, but the core product itself is open source. And so download it, get it running, and just start testing, see what kind of output you get from it, see what kind of outdated libraries you see, and just kind of get familiar with it and start there. And like I said, once you get familiar with that and you feel more comfortable, then maybe you can start looking at some of those commercial tools. You can start having those conversations with the developers. But you know, I'll remember, and I didn't put this bullet in here, but I think it's very important. It's the next step. Start small, right? So don't go in and try and secure everything at once, because number one, it can be a lot for a security person to do and get set up and working and running. And number two, the development teams will get potentially frustrated, right? Because you're taking an image and all of a sudden you're testing it for libraries, you're testing it for best practices, and you're going to kind of slow them down. So that's kind of why I take this, you know, the gradual step up. Let's start with libraries. Let's get it clean first. Then let's integrate it into your Jenkins for libraries and get that working. And then let's look at best practices. Just take an iterative approach to it, and you'll get a lot better buy-in. And from my perspective, the DevOps teams that I worked with when we implemented this, they took it and ran when you kind of went in that sort of mindset. So that's my presentation. So at this point, I'll turn it back over for any questions, if we have any questions from the audience.
Perfect. Yes, we definitely do, Tim. Thanks so much for the presentation, first of all. Let's dive right in because we don't have too much time left. First question from the audience. Can you talk a little bit about the process or steps you take after identifying vulnerabilities within an image to eliminate or respond to the vulnerability?
Sure, and it depends on the process you already have set up. So typically what I rely on I always like to use the tools that the development team uses, and so I don't like to put things in my own security-only tools. So what I typically do is when you find vulnerabilities in these libraries and you go to resolve them, a lot of dev teams use something like Jira to manage their tasks, and so I simply, a lot of these container security tools can push to those tools. And so that's typically what I do is whatever your development team, your DevOps team is using to manage their existing tasks or defects for their unit tests or what have you, I would simply utilize it, and they put it right alongside anything else that they're working on, and then work with the program, the project manager, whatever you want to call it, to make sure that those things stay in a priority queue.
Perfect. Next question is, are there any differences in securing a Windows container versus a Linux container?
No. the Windows containers, they're becoming a little bit more popular. I'll say that I've just started to work with them more in my current job. All of the containers that I worked with previously were Linux-based, and Windows containers they didn't work very well, but I know people are starting to utilize .NET, the Windows Core these days. And so the process would still be the same in any sort of measure, providing that your tool supports the monitoring of that particular operating system. So you got to keep in mind that some of the commercial tools that are out there that would do the best practices or the runtime monitoring have to be able to support the Windows operating system containers that you're bringing up. So no in theory, but you just need to check the requirements of the tool.
Okay. Next is, what is the most important tool in your toolbox if you were starting out in containers today?
From my perspective, if I'm starting out fresh and I'm not wanting to make too big of an investment, the best tool in my arsenal is going to be Anchor. That's the one that I showed you the diagram of, and that's Anchor with an E on the end. Because it's free, and so it's just a great way to get started. If you're a Tenable or a Qualys customer already, they do have some container security modules that would do the same thing as Anchor, so it's possible that you could get a trial of those or get those at insignificant cost. But Anchor I would put up there just because it's free and you could start today.
Okay. Next question is cloud security still important if you host your containers in the cloud?
Yeah, it is. So so when you host your containers in the cloud, you're just taking some of the aspects away, right? So the host security that I mentioned, item number 3, wouldn't necessarily apply because you're offloading the host. It depends on I should qualify that. There are different methods to host your containers in the cloud. If you are using Amazon or Azure's container hosting service where you don't have to worry about the host and you just throw your containers up there, then the number 3 part that we talked about, securing the host, isn't a part because you're offloading that to the cloud service provider. But the other 2 would very much still be in play related to the library part and to the Docker configuration or the container configuration.
Okay. Next question is, how much time do you feel teams need to spend learning Docker or Jenkins or Anchor?
It depends on your familiarity with and your comfortableness, if that's a word, of command line based stuff. So one of the problems that we run into when we start getting into containers and things like that is there's a learning curve. So people are familiar with Windows, and they can go and click in Windows, and they can do all of this. But as you start going containers and you start going cloud and things like that, things are much more command line driven, and you don't have a GUI in front of you a lot, right? So that's part of the problem. So the learning curve, it really depends on where you start. If you're starting from I don't know anything about command line, the learning curve is going to be steeper. If you're starting from hey, I'm decent at command line, I can get around Linux, your learning curve isn't going to be as bad, right? And I think you'll pick it right up especially from a security perspective. Things like Docker and these Kubernetes, like a lot of them are just building things in code, right? So the more familiar and comfortable you are writing in code, the quicker you will come up to speed.
Okay, perfect. Well, we have reached, unfortunately, the end of our time for the presentation. So, Tim, thank you so much for your presentation and taking the time today to present around container security. I'd like to also say thank you to every attendee for joining today's session. The recording will be available for offline viewing after this, and we will also be uploading the slides of today's presentation to this webinar, so you'll be able to download those and review those. Also, just before we go, I'd like to let you know that we do have more exciting content to share around DevSecOps. So please feel free to check out the rest of our webinars of today's DevSecOps Virtual Summit. Thank you, everyone, and thank you, Tim. Have a pleasant rest of your day.
Thank you.
Thank you. you.